Alright, so this is going to be a video explaining to you when you need to use the law of sines, when you need to use the law of cosines, or when you can just use the regular, right triangle trigonometry, SOHCAHTOA, to solve a triangle. I'm going to first tell you in about 3 different ways the actual, and I'm just going to give you the information, when do you use it, when you not, and then I'm going to explain a little deeper into why, if you care to know why, which you always should, and then I'll do some problems in the end, practice problems, okay? So first of all, you should know that the law of cosines, law of sines is a ratio, gives you three ratios and sets a proportion. Okay, law of cosines is like the Pythagorean theorem, c squared equals a squared plus b squared, but it's for non-right triangles. Law of sines and law of cosines are both useful for when we do not have a right triangle. Remember, if we just had a right triangle, we already know that one of the angles is right, then of course I could use a squared plus b squared equals c squared to find the missing sides, and if I ever have an angle like theta, I could always use sine of theta equals so opposite, which is a, over hypotenuse. Cosine is adjacent, which is b, over hypotenuse, and then tangent, TOA, is opposite, which is a, over adjacent, b. Okay, so we could use those ratios. I'm so sorry. So you could use SOHCAHTOA on that angle theta if we have a right triangle. Okay, and of course we can use inverse sine, or sine inverse, sine cosine, sine inverse, cosine inverse, tangent inverse, if we want to find the missing angle. That's for right triangles, but the law of sines and law of cosines is useful for solving oblique triangles, or non-right triangles. Okay, so these laws is good for solving non-right triangles. Those are also called oblique triangles. Okay. Now, when I say solving a triangle, you know that means to find all the missing sides and all the missing angles. Okay. So the first thing you should know, the law of sines is useful, good for when you are given the side angle side of a triangle, or SSS. Okay. The law of sines, on the other hand, is good for when you're given let's see, how can I explain it? When you're given angle side angle, okay, or angle side. Okay. Also, sometimes it works for ASS. Okay, so again, a law of sines works for ASA, AAS, and sometimes for ASS. And we'll talk about in chapter 4 more about ASS, but for now I will generally give you problems like ASA, AAS. Either way, what do you notice? We already have 2 angles. Okay, we already have 2 angles. Versus here, law of cosines is when we have 2 or more sides. Okay, so that's one easy way to think of when you use law of cosines and when you use law of sines. Okay, I want to point out something about the law of sines. So if I have ASA, okay, so for example, if I have this angle, let's say I know angle A, okay, and I know the side, let's say I have this one, okay, and I have this other angle. Okay, this is ASA, angle side angle. Geometry told us that we can prove that two triangles are congruent just because they have the same angle side angle. That means angle side angle determines a unique triangle. You're locking in only one triangle in the world can have the same angle, side angle. Okay, but think about it. If you already know two angles, don't you automatically know the third angle? Because if you know two angles and you know that the three angles adds up to 180, then you know that you can figure out the third angle by adding these two angles and subtracting from 180. So if you have angle, side, angle, you really also have AAA with a side. You also can say you have side, angle, angle, or angle, side, side. So really, these two are really the same. Okay, because if you have angle, side, angle, you can automatically do, if you guys can see that, if you have angle, side, angle like that, then you automatically have side, angle, angle as well, or angle, angle, side. So these are really the same. Okay? Alright, so the law of sines works for that. Okay, one way you can think of this is, okay, AAS and also ASA. Basically, you can think of it as this works when you have, so basically if you have, you would have all four things. You would have angle, side, angle, and the other angle. Then because if you have this, you have this, right? Automatically. Then really you have one angle and its opposite side, which is what you need for law of sines, and you have one more angle. Okay, so you have one side and its opposite angle, and then you have one more angle. So that's another way to think of it. You have to have one side and its opposite angle and one more angle. Alright? I mainly think of it as when you have two angles and you have one side, then you can use law of sines. Keep in mind that if you have two sides and one angle, you can sometimes still use law of sines, but it's a special case. It's called an ambiguous case. So there could be more than one right answer, and we have to be smart in knowing which answer to choose. Okay? Let me talk a little bit more about why this is what we need for law of sines. Okay? If you think about it, the law of sines gives us three ratios. It tells us that the sine of an angle divided by its opposite side is proportional to the sine of the other angle divided by its opposite side. Is proportional to the sine of the last angle divided by its opposite side. So the angle, the sine of an angle and its opposite side is the same ratio in all three situations here. Now, we're only going to take two situations at a time. When I set up a ratio, I'm going to say this, like those two angles and sides are proportional, or those two angles and sides are proportional, or those two angles and sides are proportional. I want you to keep in mind that what we call A, B, and C, that doesn't matter. You could call this A, B, and C, or you could call this A, B, and C. It doesn't matter. What matters is that you're keeping consistent the angle with its opposite side, angle with its opposite side, angle with its opposite side. Okay? So let's just focus on this. Okay? What do we have here as variables? What we have here as variables is some angle and its opposite side, and another angle and its opposite side. Okay, those are my unknowns or variables that I'm plugging into this equation or this proportion. So basically, if we want to be able to solve this, we need to have at most only one unknown. Okay, and everything else, so out of these four, only one can be missing, and the other three have to be known. So maybe I'm missing one side. Then I know two angles and one side. That's why I have angle, side, angle. Maybe I'm missing this one. Then I still have two angles and one side. So that's also ASA. Okay? What if I'm missing a side? What if I'm missing an angle here? Then I have two sides and an angle, and that's why the two sides and an angle works sometimes. Okay? But can I be missing both sides and have only angles? No, because then I couldn't set up a proportion. Can I be missing all angles and have only sides? No, because then I still would have two unknowns. I would not have a proportion. Okay, I hope that makes sense. You might want to, if that didn't, you might want to play it one more time. or ask me specific questions about a certain time frame in this video. Okay, let's look at the law of cosines now a little bit. Okay, now the law of cosines says that if I take, remember the lowercase represents sides lengths, and the uppercase represents the angles that are opposite to those lowercase sides. So the law of cosine says that the side squared equals the other two sides squared. It doesn't matter, there's no hypotenuse anymore. No hypotenuse because it's not a right triangle. So it doesn't matter which one, any of the sides squared equals the other two sides squared and added together, as long as we subtract by the 2 minus 2ab times cosine of c. Cosine of that side that's opposite, the cosine of the angle that's opposite to that original side. Okay, so think of it like this. C squared, this one squared, okay, equals this guy squared plus this guy squared minus 2 of AB times cosine of that angle that's in between A and B. Okay, and we could do that with any other. So we could say A squared equals C squared plus B squared minus 2 times C times B times cosine of their included angle, which is A. I could say B squared equals A squared plus C squared minus 2AC cosine B. Okay, so this one has to be the included angle between side A and B. Okay? Now, what does that look like in the end? That ends up looking like SAS and SSS. So if we're given the side angle side here, side angle side, then we can say that our unknown is C. Then my unknown missing C would equal this square plus this square minus 2AB cosine C, and we know it. So everything we would know except this C. Also, we can have side, side, side. So if we know side, side, and side here, but we don't know the angle, if we just have all three of these, then we would have C squared equals A squared plus B squared minus 2AB cosine of this missing angle C, and we would have to do cosine inverse to find out what that C is. So then everything here would be known, and the only thing missing would be this big C. So either we're missing the big C or we're missing the little c. Okay, that looks like two sides in an included angle or all three sides. Okay, last but not least, let's just go through, look at some problems. Okay, and then we'll see when we're not going to actually solve. I have lots of videos and home practice problems already to actually work on solving, but we're going to see look at cases of when we can use and when we cannot. So if you look at page 50 of your packet, okay, page 50 of your packet, number 97. Okay, we're going to zoom in on 97 of your packet. This problem asks you, which one can we use the law of sines? Okay, so let's look at this. Remember, the law of sines can only be used for ASA, AAS, and sometimes for ASS. Okay, so let's just forget about the sometimes. For now, we need to have two angles and a side, whether it's that side is in the middle or on the outside. Okay? If you think about it, if you have two angles, you have all the angles. So basically, the law of sines works for when you have, I'm sorry this is so messy, but basically the law of sines works for when you have all angles, right? All three angles and one side. Okay, that's another way you could think of it. You have all three angles. Well, they might have only given you two, but you could figure out the third. You have all three angles and you just have a side. Okay, so i.e. have all angles plus one side. Oops, plus. Okay, all right, so let's look at this. We have here, we know this side and we know this side and we know the angle in between. So this is side angle side. So can we use law of sines? No. If you think about it, if you try to right? So you can, so no, you cannot, right? Let's see, let's try. Why can't we do it? If I say the sine of angle 22 over the opposite side C equals angle what? Let's say I'm trying to work on A. Okay, then sine of A over opposite side is 6. But the problem is now I have two unknowns, right? This results in two unknowns. That's not good, okay? Because now I'm missing the C and the A, and I can't solve one equation with two unknowns. If I have one equation, I need one unknown, okay? Here we have A, B, and C. We have all the sides, okay? So we have SSS. Does SSS work for law of sines? Nope. Again, if I tried, I would say like sine of A equal over 6 equals sine of B over 8. But that again leaves me with two unknowns. And I can't solve it. Okay? Let's try another one. See, I have this side and I have this angle and this angle. Okay? That means I have angle, angle, side. Does that work? Yes, I can solve. If you think about it, I have 22, I have 78. 22 plus 78 is 100, and so that means this one is 80, since the whole thing has to add up to 180. And so now I really have angle, angle, side, but I really have angle, 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 and a side. So I also have angle, side, angle, right? And that works because look, I could go sine of, since I wanted this 8, I could do sine of 78 over 8 equals, now I can find A or C. I can say sine of 80 over A, and I could solve for A. And I could also say it equals sine of 22 over C, and cross multiply and use those two and solve for C. I could use those two to solve for C. I could use those two to solve for A. Okay? Lastly, what do I have here? I have all the angles, okay, and I have no sides. What is that? That's AAA. The donkey principle. If I have all the angles, does that determine a unique triangle? Nope. Because there's lots of triangles. Look, there's this one, there's this one, there's this one. All of these have the same, you know, there's lots of similar triangles that I can make that have the same angles. I have no idea what the sides are. So there's no way I can figure out. Plus, if I were to try it, look, I could do sine of 80 over A equals sine of 78 over B. But now I still have two unknowns, right? And I could have tried the other one, sine of 22 over C, over C, but now I have three unknowns, right? So I have two unknowns, so it doesn't work. So it only worked in this worksheet for AAS, for C. Okay? But maybe for some of these, we can use a law of cosines. Which one can we use a law of cosines? Remember, law of cosines works for SSS and SAS. Okay, so let's try that. Over here on page 56, of your worksheet or packet, we have problem 108. Okay, in two of these situations, we could use a law of cosines. Oh, wow, I think this is like the same problem, pretty much. But here we have, okay, so here we have side, angle, side, right? Side, angle, side. So we should be able to use this, right? Because the law of cosines, remember, works for side, 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 and side, angle, side. Okay, let's look at, I don't like this green. This one works, this is side, 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 so that one should work. This is angle, angle, side, so I don't think it works. No. And this one is angle, 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 and I don't think that works either. Okay, let's see. Let's just try to plug in and see, okay? So for A here, if I have this missing C, I can say c squared equals, I have the other two sides, right? So I can say c squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times cosine of c, which is the angle included between 8 and 6, across from c, which is 22. And I could do that on my calculator. I could do cosine 22 on my calculator, multiply by 8 times 6 times 2, and subtract that from 36 plus 64. So I will be able to find c. So that's solvable. Okay? Let's look at this one. If I have a, b, and c, I can say 7 squared equals, okay, let's say I'm trying to find this missing angle here. 7 squared equal, I'm trying to find this one. 7 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times cosine of angle C. Now, but I should be able to solve this. That's my unknown here. But how do I get this by itself? How do I isolate it? Well, think about it. I could do 49 equals 36 plus 64 minus, okay, 6 times 8 is 48. 48 times 2 is 48 times 2 is 96 times cosine of C. That's still the variable. And so I know some of you guys are tempted to do 36 plus 64 minus 96, but you can't because 96 is being multiplied to cosine of C. So that has to be go first before you add or subtract these. So they can't. So these have to stick together. So 36 plus 64 is 100. So 49 equals 100 minus 96 cosine C. I'm going to subtract 100 from both sides. So 100, so negative 51 equals negative 96 cosine of C. Divide by negative 96 on both sides. Negative, negative. Okay, so 51 over 96 equals cosine of C. And if I want to cosine of some angle equals this ratio, then I have to unratio or do the cosine inverse of this ratio to get back the angle. Or one way you could think of it is if I want to get the C by itself and it's being cosigned, I have to uncosine it. So I can say the cosine inverse of cosine of C. So uncosine both sides. So cosine inverse 51 over 96. So basically cosine inverse of cosine cancels out. So C is by itself and it equals cosine inverse of 51 over 96. And this is something I could easily put into my calculator to get my answer. Okay? Use calc. You later, not calculus, calculator. Alright, so I hope that was helpful. It was a little lengthy, but I hope that helps you know when to use the law of cosines, when to use the law of sines. Peace out.